Hello, my name is Aman Sharma and I am your mentor for CSE at YourPedia. So today we'll be doing a question from our NPTEL question bank series, and the question is from operating systems. You can find the question on page number 155 in the booklet, question number 23. So the question is, for implementing demand paging, it is required to. So in order to implement demand paging, what are the conditions that will be required? First is distinguish between the pages that are in the memory and the pages that are on the disk. Second is use a variation of valid invalid scheme for protection, implement a new MMU functionality, or all of the above. So in order to solve this question, firstly we should know how demand paging works and what is demand paging and why we use demand paging. So you must be familiar with paging, concept of paging. So in paging, what we do is CPU will generate what we will do is, this is a physical space, the memory of the system. This is a logical space, which is some process, and we will store we will divide the physical space into frames, and we will divide the logical space into pages. Now to keep the record of all the pages, we will keep a page table in which the information will be stored, that whether the page is stored in the memory or not. Let's say that we have stored page number 1. The page number 1 of the process is stored in frame number which is represented by bits 1 1. Now 1 1 represents 3. So page number 1 will be present in 3. Page number 3 is present in 2. Page number 5 is present in 1, and page number 7 is present in, this should be 0. So this is how paging works. Now what CPU does is, let's say that it requires to execute a part of the code which is present in some page, and that page is, let's say, page number 3. So what it will do is, offset will have 10 bits which will keep the information regarding the page, that what page is storing. And in order to find page number 3, these 3 are the number of bits in order to represent the page. So now page number 3, this we have to find, will be represented by 0 1 1, and after that there will be 10 bits for the offset. Now it will go here and it will see that page number 3 is present in frame number 10. Now frame number 10 is what? 2. So it will translate this 0 1 1 into frame number, which will be 10, and there will be similarly there will be 10 bits for the offset. Now this 10 will be transferred here using this page table. Now translating the virtual address into physical address is called paging. Now after that it will go into the memory and it will access the frame number 10. Now frame number 10 is what? Frame number 2. So frame number 2 will consist of page number 3. This is how paging works. Now let's say that there is an issue here. Issue is what? Let's say that CPU is asking for the page number 4. CPU is asking page number 4. So how you will denote page number 4? 100, and there will be 10 bits of offset here. Now when it comes to page number 4, it will see that page number 4 is not present in the memory. So page number 4 is not present in the memory. So it will follow some steps. So first step was coming here and seeing that page number 1 is not present in the memory. So what it will do is, at second step, it will tell the operating system that the CPU is demanding for page number 4 and the page number 4 is not present in the memory. So operating system will go to the process which will be present in the secondary memory at third step, and it will do what? It will fetch the page number 4. It will fetch the page number 4 which is required and bring it towards the main memory. So this is the bringing it towards the main memory will be the fourth step. And what it will do is, now main memory is full. So in order to put P4 into the memory, you need to replace some page. Now that replacement, which page must be replaced by P4, is decided by page replacement algorithm. We study that in a different module, page replacement algorithm such as FIFO, first in first out, optimal page replacement algorithm, or LRU, which is least recently used. So you can decide using those page replacement algorithms which page to replace. So let's say that using some page replacement algorithm, we have chosen P5 to be replaced. So when P5 will be replaced, instead of P5, P4 will come here. Let's write this in different color. So P4 will come here. Now at the fifth step, from memory we will go to the page table. At the fifth step, we will go to the page table and we will update the page table. Now frame number 1 is having P4 instead of P5. So we will delete this entry and it will be put here. So this is called demand paging. When you require now this is the whole process is demand paging, and the thing that happened here is page fault. That when you required some page and that page was not present in the memory, you have to bring that page into the memory and replace the entry in the page table. It is called page fault, and whole this system is called demand paging. In demand paging is what? Loading the page into the memory on demand. Whenever this is called page fault, whenever page fault is what? When you require some page and it is not present in the memory. So whenever a page fault occurs, you will perform demand paging, which will bring the page into the memory on the demand of CPU at runtime. So this is what demand paging is. Now we have understood what demand paging is. So let's try to answer the questions that it has been asking. So the first question is, distinguish between the pages that are in memory and the pages that are on disk. Yes, it is required, because if you don't know which of the pages are present in the memory and which of the pages are not present in the memory, how you will distinguish whether to replace the page or not? So you have to keep a check whether the pages are present in the memory or not. And how you keep that check? You will use page table to keep that check whether the page is present in the memory or not. It will give you the information regarding that. So first statement is correct. Now second statement is, use a variation of valid invalid scheme for protection. Now these pages are very long. So what you instead of searching for the whole table, what you will do is, how we tell that whether the page is present in the memory or not? Because here I have just written 01, but actually there are lot of bits in that, and if the page is not present in the memory, then also there will be some information present in that. Okay, so if all the pages have all the page table entries have some information, you need to have a certain bit to represent whether that page is present in the memory or not. So there will be a separate bit, valid or invalid bit. So if the page is present in the memory, it will be 1. If not, it will be 0. So all the times when the page is present in the memory, the bit will be valid, otherwise it will be invalid. So in order to keep check whether the page is present or not, we will be using valid or invalid bit in the page table entries. Third is implement new MMU functionality. Obviously you have to do everything differently in demand paging. So you have to implement new MMU functionality. So all of these conditions are required to implement demand paging. So I hope you understood the concept. So keep watching for more interesting videos like this and keep preparing. Thank you.